A flat dielectric disc of radius r carries an excess charge on its surface. The surface charge density is sigma. The disc rotates about an axis perpendicular to its plane, passing through the center with angular velocity omega. Find the torque on the disc if it is placed in a uniform magnetic field B directed perpendicular to the rotation axis. Now consider a disc of radius r which is rotate about an axis omega and its radius is r, and the magnetic field is perpendicular to the rotation axis, so magnetic field is directed to this direction. Now surface charge density is sigma. Now we consider a annular ring of radius r and r plus dr, annular ring of radius r and r plus dr. Now the area of this radius between r and r plus dr, that is dA, is pi r plus dr whole square minus pi r square. So pi into r square plus 2r dr plus dr square minus pi r square. Here pi r square plus 2 pi r dr. Since dr is small, so the square of this value is also small, so it tends to 0. So this is minus pi r square, so dA is 2 pi r dr. Now this charge on this annular ring is dq समान sigma dA, so 2 pi r dr into sigma. Now the ring rotates with an angular velocity omega, so the frequency f समान omega by 2 pi. Now the current, that is I, is equal to q by t, that is q into f. Here q is 2 pi r dr into sigma and f is omega by 2 pi. So current is I equal to sigma omega r dr. So the magnetic moment m is I into a. Here I sigma omega r dr and a is pi r square, and torque d tau is mb sin theta. Here angle between m and b is 90 degree, so this is sigma omega r cube pi b into dr. So the total torque, that is 0 to tau d tau equal to sigma omega pi b r cube dr. Here r is in the limit 0 to r. So tau equal to sigma omega pi b r to the power 4 by 4. This is the total torque acting on this disc.